Hello, am I audible?
Yes, Pankaj, you are audible.
Okay. So good afternoon to all of you. Good afternoon to all of you. Thank you all of you for joining this webinar. So today the webinar topic is smarter plastic part design, predict, prevent, and perfect with SolidWorks plastic simulation. So today I am your host Subhankar Singh, application engineer simulation at AI Design Solution Private Limited, and along with me is joining Mr. Gautam Srinivas, who is industry process consultant simulation from the Dassault system. So we will be hosting you today and we will talk about plastic simulation, how it will help us to reduce our cycle time and to detect early the defects which we face in plastic design. So I will start the session with the poll. So first question is, what is your current role in your company? So the poll will start now and you will have 60 seconds to answer the poll. So as you see, plastics are everywhere. If we look our surrounding, most of the thing is made from plastic. Let's talk about transportation and mobility. Suppose we come to our office through a car. So in car also, we have a lot of plastic components. Then if we look at our mobile phone, refrigerator, washing machine, most of the parts are from plastic component only. So if we talk about life sciences, medical devices also, like blood pressure monitor, injection, these are all made of plastic components are only. So in these plastic components, almost 80% plastic components are made by using injection molding process, injection plastic molding process. So if we talk about the how we manufacture plastic, so it is not an easy task to manufacture plastic because we can get a lot of defect during manufacturing of the plastic during injection molding process. So first defect can happen is air trap with burn mass, as you can see in the slide. Then we can also have short defects where the molten fluid is unable to reach to its final destination. So it freezes early. Then we can also get sink marks, which which is not good for our aesthetic. Then we can also get unwanted wet lines. So these defects can uh, due to these effects, the quality of our product decreases. So which can be a huge business loss. Then what are the designers' challenge during plastic part design? So I will talk about these challenges. So today, most of the designers design their parts by their gut feeling or experience. So what are the consequences? Like they do not have any validation tools, so they design only by their experience or gut feeling. So due to this, the mold maker identify issues in the manufacturing phase only. So in the later phase, they want to change the design, which becomes very costly. And also designer make changes with no guarantee of solving the problem because he's changing the design by his experience. So it is not sure this design will be helpful. So this way the cycle repeats. In one cycle, he identify one problem, then repeat, then modify the design, then in another cycle, he get another problem. So this is a very repetitive task. Next slide. So let's talk about cost of change versus impact of change. So let's say we are designing a part. So during design, if we are able to get the problem in our part, then if we change in the design phase itself, then the cost of change will be very less. But in later stage, let's say in mold design, we want to change the design, then cost of change will increase. And if we want to change the design in the later phase, like product launch, then cost of change will be very great. So as you can see, in later processes, the cost of changes increases. So what if we have a tool which give us the result in early phase and we can change the design in early phase only to reduce the cost. Next slide, please. So now let's see how we can reduce our cost by using our solution, SOLIDWORKS Plastics. So in this video, you will get to know about our product.
You've designed a great new plastic product and you need to get it to market quickly. So you need to optimize the parts for injection molding, which means you need to be sure the part thickness is uniform and won't warp, that the mold fills properly, that there are no defects such as blemishes, air traps, and flashing. The mold needs to be perfect the very first time or you will quickly be overcome with sinking profits. There has to be a better way. Enter SOLIDWORKS Plastics. Using SOLIDWORKS Plastics is the most efficient and accurate way to validate your plastic designs before you start injection molding. In a matter of minutes, you can easily test your designs for proper fill, best injection location, and potential product defects such as weld lines, short shots, and sink marks, all within the SOLIDWORKS interface. SOLIDWORKS Plastics takes the complexity out of testing your designs to ensure you get the mold right the very first time. It does all of the complicated calculations for you, so you can focus on designing. SOLIDWORKS Plastics works directly within the SOLIDWORKS interface, so you can validate while you work. You'll create the best design the first time, every time. To learn more about SOLIDWORKS Plastics, contact your SOLIDWORKS reseller or visit our website at www.solidworks.com. SOLIDWORKS Plastics. Eliminate costly mold rework. Improve part quality. Reduce time to market.
So now I'd like to invite Gautam sir to continue the webinar.
Yeah. Thanks, Pankar. Hi, good afternoon, everyone. So as Pankar said, like plastic injection molding is not an easy task. That to like achieving like the goal or a first proto as a successful as it's a tedious job. We need to go with a lot of design ideas, design revisions, mold tool redesign to achieve our goals. So I like to take all of you through a case study, which we had work for one of the customer. Like their product is My Pro. It's like an if you see, it's an orthotics. Let's say if there is a bone fracture or like a disability, so this robo will help them to bring back the mechanisms. So in this robo, like My Pro is a robo where it is electrical device control. So here we have the battery pack within this. So the product which we going to do analysis is over this battery pack cover. So this is a back door where it will be like now open and close and we loading the battery inside. So here you can see there are some snap fitters there. So here there is some gear mechanism which will be mounted over this component. So what objective we have in this is like we need to review the design. Let's say like whether it is good designed with adding some fasteners into it for mounting. And we need to check for the draft and thickness of that component because that is very crucial for any molded components. So it need to have a perfect draft angle and thickness distribution. Why so thickness is like to avoid the shrink mark, those stuffs. Typically, there are multiple approaches to do that. I will take you through one of the approach. So post we reviewing the design, now we're going to do the testing, preliminary testing on the first design, like initial design, to check for the manufacturability. And if there is any flaw in the manufacturability, we're going to redesign the component and redo the analysis. So I'm going to show you like how this design integrated analysis tool will help you to save lot of time and explore lot of designs, like many design approach ideas. Then finally, any work need to be get documented. So I'm going to show you how we can easily build a report and shareable documents. So this is what we're going to follow. I will take you through the user interface. So the tool we're talking here is like a SOLIDWORKS CAD with the simulation and the plastic injection molding. So I going to open this file like the door mechanism for this analysis which is attached to the main assemble. So if you see this one, it's like on the curvature phase, and it has all the ribs which is attached to that, and you can see there is an gate is built which will be helps to like open and close with a spring mechanism. The spring is attached to the support elements. Okay, so which bear some, which is the load bearing phases. And if you see at the top, we have the fastness like a snap fit will be there. So we need to place this snap fit over here. So I'm going to edit this model. So I will showcase you how easily we can build this snap fit. Okay, so like a SOLIDWORKS CAD is very easy to design, and it has lot of automated tools which will shorten your design cycle time. Um, so here I going with a dedicated tool set for fastener features where you have the mounting boss, snap hook with the groove, and we have the vent as a separate tool set. Where for any electronic components, we need to plan for the venting system. So very easy. This tool will help us to build that venting very easily. And also we have the lip slash groove options also. So we going to pick the snap hook. So I will which is needed for this design. To building this, it's a like a build a library. So simple thing is you need to define the reference where this snap hook need to be get attached to. So with a three coordinate of reference, the already pre-fitted the shape will be there, and also we have an complete control on the parameters for the snap hook. There you can directly feed in the parameters, let's say the head size or neck thickness and the span of the snap hook. And also you can save once this parameters you can save as a favorite, by that you can reuse. So once it is done, so I'm going to mirror this snap hook to the other side with using the symmetric plane. Um, which is way more easy and quick to build. So my design is done. Let us validate this component. So before going for injection molding, as I stated, like we need to do a couple of testing. Let's say the draft analysis and the thickness analysis over this component. So first, what we are going to do, I going to conduct the draft analysis. So it's a very easy. Just we need to pick the partition plane or the surface, and you can define the angle, like what draft angle you are expecting. So within the seconds, it will be highlighting where you have the positive draft, where you have the negative draft, and where the draft is required. So instantly it will highlight, and it also gives you a good view about how much draft is there in the each faces and the surfaces. So instantly you can modify the draft angle in the CAD. So next important aspect is the thickness analysis. So we need, because we need to maintain a uniform wall thickness, or if it is a complex geometry, we need to check where we have the very thick and thin areas. So by defining a neutral thickness size and calculate, so it will be calculate and give you an instant preview about where we have the where we have the more thick regions, which highlights in the blue region, and where you have the very minimal thickness, which highlights in the red color coded. So even we have the probe options where you can pick on any of the surfaces or newer cursor and through the component which shows what the exact thickness at each faces. Typically, where the ribs are there or any supporting elements are there, the thickness will be more. So if it is within the acceptable limit, we can move on to the validation stage. Now my design seems to be okay. So let me check with the manufacturability of this component. Okay. So we had reviewed. So I got like I have spoken in the design stage. We need to do the thickness analysis and draft angle before moving on to the simulation. And we do have an inbuilt fasteners library where it is very easy to build those mounting bars, snap hook, or even as grooves we can build. A vent we can design, which is much needed for any of the plastic component, which is easy to build with the solders. So let me take you through the validation stage by switching to my sawdust window. We can make it as a configuration by exploring various designs. So this is the tool which I'm going to take you through. Sorry, one second. I need to switch my screen. Mm, Yeah. Hope my sort screen is visible. Can anyone please confirm?
Yes,
Yes.
it's visible.
Yeah, thanks. Um, here, once the design is done, we can enable this sort of plastics, which is the tool I'm going to talk about. So this comes as an add-on to the existing sort of 3D CAD. So here we can able to set up the process which I want. Either I want to do a basic fill analysis to know about the filling time, filling pressure is required, and the basic defects identification like weld lines, air traps, string mark, those stuffs. If you're crossing the field, like if you want to validate on the pack stage to know the packing pressure, or if you want to know about the cooling layout analysis, like how effective my cooling layout is, how much heat fluxes get transferred, and how much temperatures get reduced. And we can also conduct the warp analysis to check for the shrinkage and residual stress developed in the component. And post you defining that, we can pick the machines and also the materials. So for materials, we have a huge material database, engineering material database, which consists of around 4,500 variants of material with all the major metal manufacturers. So you can go through any of the material. Let's say if you're going with the basic, within that also we have various grades with various blends. You can able to pick. So all the material will be detailed with all the parameters. Let's say the metal parameters data. One second. So all the parameter data will be available with the PVT curve, temperature like a thermal conductivity, and curing method, and if the glass touches temperature, all the things are pre-feeded. It's not only with the polymers, or if you have any inserts or coolants, we do have a detailed library for the inserts or the various coolants, which you can directly apply and check for that. So once you define the material, we can able to set up the process conditions. Let's say the melt temperature or mold temperature, it will be automatically taken from the metal library, or if you want to edit or modify, you can play with and even we can able to define what my maximum pressure limit of my machine, that you can able to define, and the switchover conditions you can able to define. So these all are various machine parameters you can able to control. So here we have two options. Either you can go with the manual approach where we will define the data, or we can ask suggestion from the software, like with automated approach. So it will give you what are the parameters you need to feed into the machine. So under the domain, I define this component as a cavity. So this will be treated as a cavity. So for injection location, for first cut of analysis, I need to place the injection gate over this area and calculate how much it will be filling. Or else we have other options like we can ask software to guide us like where we need to place the injection locations. By that, it will predict and tell you like if you define I want to place two gates, it will be guiding you where to place the gate. Okay. Apart from that, we have many more options for fill settings like how my product is get oriented, whether I need a vent analysis or not. So those stuffs you can able to set up. So I will show you an initial level of results. Let's say for this gate location and for my initial design, it required around 1.07 seconds to fill. Even we can animate and see virtually how the resin is going to fill my cavity. So at any time you can pause and review the results, how it is getting accumulated or it getting filled. Even we can able to find what pressure is required to fill this cavity. It's around 12.9 megapascal of pressure is needed to fill this cavity. So whether any shrink mark will be developed in this component, yes, a shrink mark of around 72 microns will be get built over these regions. And in this regions where you can see the traces of the rib now over the outer surface, whether this is exposed surface for the which affects the cosmetic or aesthetic look of this component. And one more thing I want to know about the whether let's say where the weld line is getting occurred. So weld line, you can see there are multiple weld lines where the flow front is there. Where here I can find some weld lines, and here also where this is the most like crucial part where the load bearing area we have. So I will compare with the flow front temperature to identify whether this weld line is the safer side or not. But I could see it's not on the safer side. Um, so what I want to do, I need to change the gate location because the design control I don't have. I'm going to place this gate to some other area. Let's say this zone which is not exposed to the outside, exposed outside. Because if you place the gate, it may affect the aesthetic. So I'm going to place the gate over here. So for that, and one more thing I want to do is to avoid this snip mark. So I want to change the thickness of this component. So instantly I can go back to the design. I can edit the parameters. For time constraint, I had made a configuration for that. Instantly I can switch to the various design ideas. Um, so once the switching is happened, you don't need to set up the entire conditions again. Like say what I had defined in the early studies, I don't need to define everything again, like material definition or the machine parameters. It will be get copied automatically. Only thing this injection location and go, I can edit and I can relocate to the area where I need. So I had chosen this area with 1.12 of gate size. So let us see like whether this will create any impact. So post solving this study, as typically we can able to find how the resin is getting filled. So I'm going to do the animation again. So now I can see like this areas get filled first, then it is propagating to the entire region. So how much time it took is around 0.74 seconds it had taken, and pressure of around 36 megapascal it required to fill this cavity. So I will review this weld line. Anyway, weld line will be there. So if we compare with the flow front temperature, this is in the hot zone, which is a safer thing I can say. So it won't create that much a defect in this component. And if we review on the sync mark, so now it is bit reduced. The traces, like the rib tracing is little bit reduced at the outer surfaces because we played with the thickness of this component. So where the air traps will occur. So air traps will be there here, here, and here, and a couple of in the this rib regions and the gear regions. So if you want to know whether we need to place a venting over this, so we can also do the vent analysis to validate this. So let me see like how much packing pressure is needed. So packing pressure is required for this component is around 18.94 megapascal, which is needed. And post packing stage, what's the volumetric shrinkages? We got around 9.4 percentage of volumetric shrinkage is there in this component. So let me review like a post ejection, how much it going to shrink. In the warp results, we can able to find the total displacement. So this component going experience a displacement of around zero point 0.4 mm. So which will be shrinking at this kind of moment. Let's say in the z directions. So we can able to switch with the various coordinates. Let's say in the z direction, how much is shrinking. So in z, it is around 0.35 mm, and in the y, it is around 0.24 mm. So this is the y shrinkage conditions. Even here also you can see. And in the x-axis, it is around 0.24 mm of displacement you will be experiencing, like a post-adjacent conditions. So what about the residual stress? So in mold residual stress is around 1 second. So this is displacement. So in mold residual stress is around 26.73 megapascal will be experienced post adjacent conditions. And demold residual stress is around 33.54. Are we going to this comment going to be experienced? So like that we can able to check in detail about how easily or how effectively we can manufacture the component by exploring various design aspects. Since it is very much integrated with the CAD, anytime you can go switch back and you can edit the parameters, you can come back to the validation rather than the study. And whatever design thoughts you have, you can put on into the system and you can study those stuffs. Um, and by that, what the main benefits we'll be getting is like, 1 second. We in this design, the initial design is filled with 1.07 seconds with a 12.82 megapascal, where the weld line got occurred. So we did a design change, reducing the thickness, and also we moved the gate to the bottom area where which is won't be exposed. So by that, the time also reduced, the filling pressure is reduced, and more majorly the aesthetic won't be affected much compared to the early design ideas. And we shifted the, let's say that we made this a region as a safer zone, the load bearing region as a safer conditions. No, but post doing all those analysis, we need to document the study. For documentation, this tool, sort of Plastics has an automated approach where it will create the reports automatically without any human interference or the user interference into both format, let's say Word format or the PPT format. So let me show you one of the report. So it will add the product image with detailing all the condition. Let's say the metal property and the machine property and the machine conditions, like machine parameters, and the fill profiles, and also detail about the, let's say, the solving time taken, and how it is got filled, how much pressure, all the plots which we had explored, and the analysis is got filled, and even we'll get the fill balance study with the graphical approach, how equally it get volume is getting filled throughout the entire fill time frame, which is very important for any engineer to check with. So fill balancing is needed. With all the profile settings, you will be having those data. Okay, so this report will be in the Word format, in the editable format. By that, you can add your own messaging at the end, which you can communicate to the other people's, like non-analytical people, so who doesn't need a software, they only want to see the results. So in that case, it will be very much helpful. It will be available in both Word format as well as in the let's say PPT format. So next thing is I want to make a quick decision, if I have my manager, I want to have a detailed view about the results. So the Word file or PPT file, it won't have the 3D data. So other the tool which I'm talking about, the e-drawing, which comes as a free application for all the Sodos users, which are available in our websites also, which can be installed in either in Android devices or a Mac or in any computers. So you can export the plots, let's say the fill plot or pressure plot, whatever plot you have, that you can export. By that, you can share with the manager or anyone, vendor or a customer. They can open this file, they can rotate, zoom in, they can take a section view, they can animate the results, which will be very more effective way. And even they can convey you whether this is got approved, stamping they can do and share you back, which will be very effective way and a detailed way of communicating between the uh, teams. So this is another beautiful tool for a communication purpose. So basically, for any validation people, what are the building blocks they have? Fundamental building blocks that they need to rely on the solver technology, which we have a world-leading solver technology with Sawdust platform. And the second aspect is a meshing technique, mesh technique, which converting the CAD model into mathematical model with capturing the exact 3D volume, where you can rely much on because we have all the meshing techniques with us, which will be more robust and would build the data very lightweight for the solving. But more this relying, but the most important aspect is the material data, because material data plays a major role in result accuracy. So where I said like we have 4,500 plus material properties with us, but you can say how to rely on the material. In that the case, like a Dassault system partnering with all the world leading polymer manufacturers, if let's say like a Sabic or Polyplast, or Mukon or whoever you name it, we are collaborating with them. So what we do, we typically will have a talk with the people. Like every year we will upgrade those materials which are newly available in the market. We'll be adding to the metal library, and we also keep removing the outdated materials. What the other question you have, if I am going to have an customized material for my product, how you going to fit into the validation? In that case, we can help you. Like if you share the metal grade and a supplier name, we Dassault system will directly talk with that polymer manufacturer, and we will fetch the data. We'll do all the data review, data fitting, data correlations, conversions, which are very more expensive to do that, but we bear that cost for our customers, and we conduct all the study, and we will provide you the material data for validation, with a sort of passive will attach those material. So this service we doing for free of cost. So why we doing that is to improve the result accuracy for you, because material plays a major role in the result accuracy. So when you talk about the result accuracy, SABIC, one of the leading polymer manufacturer, they had conducted a series of correlation test. So this component they had took. So you can see like this way more complex component, which where the wall thickness will keep on varying throughout the span. It has lot of holes, tiny holes with the slots, and the clearance will be very very minimal between the holes. So this left hand side is a software result, and this right hand side is a like a mold results, the lab proto results. So they stopped at 10, 20, 30% of filling. So where you can see, you can compare with the results where you can see the exact flow print or the resin filling surfaces is matching as accurate as the software results. So this is like a 40, 50, 60 percentage filling conditions. You can see how the profile is exactly matching with the testing, like software testing results. So this is one of the case study. We have many more case studies. We keep developing or people are keep conducting. So where you can rely like 100% can rely on the solver and mesh properties or the material database we have. Um, so typically we will address like all the defects, mold defects we can able to address with SOLIDWORKS Plastics. Either where to place the gate and whether I will experience a short or not with the thin wall conditions, and where will be the flow front, and whether the weld line got developed will be safe or not. And if you have any fiber enforced molding, we can able to check for the fiber orientation and percentage of fibers in the mold. Based on the various testing conditions, we have listed out what are the testing ability we do have. Starting from basic field analysis with the basic level of defect predictions to like gas assist molding or multi over molding or insert over molding or let's say the fiber assist molding, even vent analysis we can able to do. So if you have a multi cavity mold or a family mold, the runner balancing is will be the very crucial task, where this orders plastic has an automated tool where it will advise you like where which runner size, gating size, or the entire layout, how we can able to balance those automated approach. Software will be giving you with the optimized design outcome results. So post the filling condition, put adjustment conditions, how much my component is going to shrink, like warpage is going to experience, we can able to check. Even with if you have a huge mold where you need a coolant layout, we can plan for an optimized cooling layout and we can check for how much heat energies get carried out from the system that we can check. What are the typical benefits people will be getting is like predicting and avoiding the manufacturing defects in the early stage. Let's say in the design stages of as Subankar has said, in the part design stage itself, if you bring a major impact and choose a best design, you can save lot of time and efforts in the manufacturability, like post manufacturing or uh, out of post product launch. If you find a defect, then it will be more expensive, which you can predict. And you can explore any number of design ideas, so which will be you can come up with a lot of innovative thoughts if you have this kind of validation tool and validate your designs in the design stages. So rework will be avoided, and the cost of prototyping will be avoided. And so these are the key benefits people will be achieving by implementing sort of plastics. I just a last poll. I request you to just drop it in the chat box. So what the question is like, what do you think about being able to validate manufacturer plastic part early in the design stage? Whether this will be, whether if you found this will be a great idea, where we can contact you for further discussion. So you can on the chat box you can drop it as an A, drop your answer as an E, or the second option will be the sounds good. So if you need more information, so we can mail you a couple of documents on that, or we can do a demo for you. So if you're interested in that, you can answer as B. And if you don't want just for a learning purpose, you can explore this webinar, you can opt for C, not for me. I think it over either you may need a futuristic way, like in the future projects, you can answer at C. So please post your answers in the chat box, which will be easy for us to communicate to you back. I like to discuss you about two customer case studies. Okay. Subankar, can you please help us to understand this case studies?
Yeah. So first, I will talk about Carlisle food service product. So they are basically into food service and hospitality, sanitation and cleaning. Their product include cleaning brushes, tools, mops, brooms, and other janitorial equipments. They are also in trade, dishware, and delivery system for hospitals and healthcare facilities. So what what let's talk about the challenges which they were facing. So first challenge was they needed to reduce cycle times, cut reliance on outside consultants, and lower prototyping cost for increasingly complex injection molded products. So they implemented SolidWorks simulation for in-house mold filling simulation. So with the use of SolidWorks plastic simulation, the cycle time reduced by optimizing gating and cooling channel designs, and annual time saving was reduced by about 12 to 15 weeks. And if I talk about costing, they saved about $20,000 per year. And they also gained confidence in manufacturability of the complex parts like dishwasher cupid holders, cup holders. So these were the benefits which they got. And if we talk about their engineer Brad Tillman, so he said software is ideally suited to the type of product that they design and manufacture. Now I will talk about another customer. So they are Eco. So if we talk about their product, Eco design emergency and warning lights like LED roof, light bars, mini bars, directional LED, LED in the flood spot, etc. So their challenge was like they wanted to eliminate mold related manufacturing issues, and they wanted to improve optical lens performance and reduce costly iteration with tool makers. So they adopt by our SolidWorks Plastic Professional. So by integrating our Plastic Professional software to their SolidWorks CAD software, their design cycle reduces. So they got faster design cycle, and the product quality also improved a lot by optimizing their stiffness or mold fouling and lens optics. And product aesthetics also get enhanced. And finally, the cost was also reduced by avoiding rework and tooling delays by validating manufacturability upfront. So these were the impacts which they got after implementing SolidWorks Plastics in their product portfolio.
So we will be sharing this case studies post this webinar, so you can go through the document. So now we came to the final slide, questionnaires. So you can post your questions in the chat box. Me and Subhankar will be answering your questions. So if you have any questions or any clarification, you can drop it in the chat box. So we'll be answering to that.
So we got our first question from Neeraj Kumar. So he's asking things not clear how this tool facilitated to plastic part design easily before molding.
Okay, so you want to know about before molding how we can optimize the design. As I said, yeah, if you think about the traditional approach of what we follow, we will design a plastic component, then that plastic component will be moved on to the mold design. So in the mold design, they will be building the mold, and the post injection, like injection molding, we'll be coming to know what are the defects is experiencing. So or it may have some drawbacks. In that case, again we need to move on to the design stage to redesign the component. But again, what the flaw here is we can't transparently see how the resin is getting filled in the machine. So which with that difficulty, we need to go with more of our assumption approaches or ideas with our experience to redesign the mold or the component. So in our case, in our workflow which we are suggesting, so while you are designing a plastic component, there itself you can able to check for how this is going to be get manufactured, like placing a gate and choosing a material and to solving the study, and you can find how the resin is going to get fill the cavity, and if it is a very thin component, whether it will experience a short or not. And if any air trap is there, we can check for the vent pressure, and we can plan for the proper venting vent locations. So, in design stage itself, you're going to check for the manufacturability, and if you found any flaw in the analysis, in again you can redesign. So with I-30 method or with automated method, you can able to get optimized component design, plastic component design early in the design stage, which saves lot of time and money on building a number of repetitive protos. So that the approach we are suggesting. Hope I'm answered your question.
Any other questions?
You can write back to us at any time. You can reach out to us either post this webinar. We'll be sharing the case studies and our contact informations. We can reach if you want more detailed presentation, because due to time constraints, we had showed a generic content, but we can stitch the content based on your requirement, and we can discuss more on the solutions for which are addressing your product development, so that we can support you. You can write back to us post this webinar. So if no questions, we can end this section. And once again, thanks everyone for joining this webinar. Hope we had given quality content to you. Anyway, we are ready to work with you. We're happy to reach out to you again. Yeah. Thanks everyone. Thank you all.
Thanks,
Bye.
everyone.
Yes, sir. Yes, we can check for the snake mark, where the snake mark going to occur, and how much at percent, let's say, and the how much is going to shrink, and the volumetric shrinkages we can check. It's doable. So we got another question from Manoj Gupta. Sodas has latest metal library. Yes, sir. We have latest metal library. Every year we keep updating the material. Let's say last year we had added 215 new variants of material from 7 different polymer manufacturers. We keep updating the material. Or if you have any custom metal, that also can be added to the metal library. So if you share us with the metal grade and the supplier, we can talk with them. So polymer manufacturer, we can talk with them, and we can fit on the curve data. We can do data validation and provide you with the metal file for a validation. So Indresh and Saravanan had requested, Sir, could you please explain in Hindi? Okay, sir, we can connect you directly, sir. We can do an detailed demo on your native language. We can connect back post this webinar. Subhankar, please connect with, please get the contact info from Indresh and Saravanan.
इंद्र जी, मैं आपसे कनेक्ट करूंगा। जो भी आपके डाउट होंगे मैं आपको हिंदी में एक्सप्लेन कर दूंगा, या जो भी हमारी कैपेबिलिटीज है सॉफ्टवेयर की वो भी मैं एक्सप्लेन कर दूंगा आपको।
ओके सर।
अभी भी कोई है तो आप पूछ सकते हो, मैं हिंदी में बोल आंसर दे दूंगा।
नो सर, बस मेरे को वही देखना था सर। इसके अंदर एक्चुअली क्या है, हमें ना लेटेस्ट अपनी लाइब्रेरी अपडेट करनी है, लाइक दैट मोल्ड विजार्ड होता है ना, उसके लिए सर। जैसे उसके अंदर मिशूमी के पार्ट्स हो जाते हैं, एंड बुश पिलर वगैरह, लाइक रिटर्न पेंस वगैरह, एक्सेट्रा, ईटीसी।
ओके मोल्ड विजार्ड किल में मटेरियल लाइब्रेरी ऐड कर।
यस सर।
Okay. So, hello, Gautam sir.
Yes, yes, Subhankar.
So his question is like he want to add material library in mold wizard.
Mm.
So in mold design, I think mold design.
Yeah, so the metal library, right?
Yes. Yes.
Yeah, we can do. It's doable. We can do so. We can support it.
Yeah. Any other question?
No sir.
We have got another question from Manish Kumar.
Mhm.
In what situation might other tool still be required? Like, can we rely on the result?
Other tools means can I please detail it, sir? But if you're asking about relying on the results, yes, you can rely on the results. We have many customers in India and too in abroad because our tools are way more decade old tools and it has been used in many companies, many corporates and government sectors. You can rely on the results because we support you in all the aspects. Like it's not like our support is not in the post selling. Post selling will help you in implementing the tool, like providing a tailor made training for you based on your product, our flow or the testing conditions. We can provide you a detailed training program until your first proto is done. We will be supporting you, and if once we gotten confidence like you are independent enough to conduct the simulation, until that time will be there with you, sir. You can completely rely on the results because we had many research has been done, and many institute had done the correlations test which are matching with the machine manufacturability in the lab. Yeah. Thank you. If you have any more questions, please reach us back. I hope in the chat box we had dropped the mail ID and mobile number. You can connect with us and we can connect directly with you and do a detailed demo with you, or have much more like many topics we can discuss in person. Okay. Thanks everyone. Thanks for joining this webinar. Thank you. Bye.
Thank you. Thank you. We are closing the session.
Do subscribe our channel and hit the bell icon.